everyone, welcome to Rupa's online tutorials. So today we are going to learn about another important operation on data structure known as searching. What is searching? In simple terms, we are searching for books, we are searching for shoes, we are searching for this, that. So a lot of searching we do in our lives, but here we are talking about arrays, or we are talking about data structures. So related to that, we are going to talk about searching. Okay, so the definition of searching here is finding the location of an element in an array. Finding the location of an element in an array is known as searching. What do I mean by saying finding the location of an element? I'm going to take one element, okay, which is known as a search element or key element, and I'm going to look whether that particular element is present in the array or not, and in which place or which position it is found. If it is found, if it is not found, I'm going to say search is not the element is not present or search is not successful. Okay, that's what you mean by saying searching. So there are two types of search that you have to learn in your syllabus. One is known as linear search, also known as sequential search, and the second one is known as binary search. Okay, so today in this video I'm going to tell you about linear search. It's a very simple search, very easy to understand. Yes, so what do you mean by linear search? See, the linear search definition is given here. In this type of search, the key element or the element to be searched, that means the search element, okay, is compared to each and every element of the array. That is from beginning till the end of the array. That is known as. So here I have taken three colored pens, red, blue and black. Now let us say that I have to search the blue color pen in this. So what I'm going to do is, I'm going to just take the search element. Okay, here I said the blue color pen. Yes, so I'm going to take the blue color pen and I'm going to compare with each of the pens I've kept here. I'm going to check whether the blue pen and the red pen is matching. It is not, so it is not the element that I'm finding. Now the blue color and the blue color pen, yes, this is matching, so my search is successful. So I don't go to the next elements. So this is what happens in our linear search. Sometimes I will be searching for a green pen. Then what happens? That green pen is not found at all. Then I will say that the search is unsuccessful. But here we will be comparing the elements of the array. Known as sequential search. So somewhere if they ask you, oh, what is the other name for linear search, you should say it is also known as sequential search. Sequential means one after another. And it can be done on both sorted and unsorted arrays. What do you mean by sorted arrays? I told you what is sorting in one of the videos. Arranging the elements in an some order. Unsorted means the elements are not arranged in any order. It can be a random number of elements in the array. So linear search can be done on both type of arrays. So let us take one example here. So I have taken one array here and it contains how many elements? 1, 2, 3, 4, 5, 6 elements. Okay. So it will start from 0 to n minus 1. So this will be 0, 1, 2, 3, 4 and n minus 1 is how much? 6 minus 1 will be 5. Okay. And now I'm going to just put the elements of the array that I have taken here. Okay. So here I have taken 11, 15, 10, 11, 40 and 25. Okay. Now in a linear search, okay, I told you there will be a key element. Okay, you can see here key element or the search element. Okay, so the search element, let me say that I am searching for a number here, say 40. Okay, so 40 is my search element. I'll just put this here. 40 is my search element. Now what actually happens in a linear search is, we are starting from 0 up to n minus 1, that is here in this case it is 5. So for the I equal to 0 to n minus 1, we are going to compare this 40 with each of these elements present here. Okay, so we are going to first go to the first element in the array. So we will say, is 40 equal to 11? Is it true? It is false. Next we are going to compare this. Is 15 equal to 11? Okay, 40 equal to 50. Okay, 40 is equal to 50. Okay, first we will compare 40 is equal to 11. Second time we are going to compare 40 is equal to 15. Again that is false. Next time we will see is 40 equal to 10. Again that is false. Next we will say 40 is equal to 11. That is also false. Is 40 equal to 40, the fourth element? That is correct, that is true. So that means what? The element is found. Okay, so are you able to understand this? So we are actually traversing the array from the beginning to the end. I already gave a video on traversing, isn't it? Visiting each and every element in an array. We should relate one topic with another and it becomes easier. So you're traversing the array from the beginning to the end, and once you find that okay, both the elements are matching. Okay, so our 40 here, this is our key element that is matching here. What will we say? We are saying element is found. This is what happens in linear search. Okay, now what do you think will be the advantage or the disadvantage of this linear search? So here you are having 11. So here also 11 is there. So that possibility is there. Okay, two numbers are there also. We are only searching for the element. If 11 is found in the first thing, then we are lucky, isn't it? The search element. Let us say now we will go, this is case 1, okay, where we are just searching normally. Now let me put one more case. Okay, now the key element that I have, okay, the key element that I have is 11, the search element. Okay, key element or search element, whatever you want, you can call it. So what happens here? The first element is what? Now I am comparing 11 is equal to 11. It is true. Then what happens? Your search is immediately done. Don't you think that's a big advantage? Now let us say the case 3, my search element is 25. Okay, so if it is 25, what happens here? This 25 has to be compared with 11, one search. Again 25 will be compared with 15, two search, with 10, third search, then fourth search, fifth search, and then on the sixth search only you are able to get this value. Now our number of elements is only 6. No problem, it is doing. Imagine there are 1000 elements in an array or 2000 elements in an array. Then it becomes an issue. The time taken is more. So that becomes a disadvantage of linear search. Okay. So that is a disadvantage of linear search. And sometimes one more case is there. Okay. I will put it. Now I am searching for an element 50. Can you find 50 in this array anywhere? No. Because 50 is not found in this array at all. The elements are 11, 15, 10, 11, 40 and 25. Again what happens? This search is not successful. Again that forms a disadvantage. So here I have just mentioned it. What are the advantages of linear search? If the search element or the key element is at the beginning of the array, the search operation is fast. And what is the disadvantage of linear search? If the search element is towards the end of the array. Okay, it is towards the end of the array or the element is not present in the array, then the time taken is more for the search operation. Is this clear? So this is important, advantages and disadvantages of linear search. Okay, now we are going to write an algorithm. Okay, write an algorithm to search an element in an array using linear search. So this is an important question. It's a 5-mark question. It was asked last year. Write an algorithm to search the element in an array using linear search. It's a very easy program. Okay, as I explained to you, if the elements are compared, okay, here, isn't it? You're just comparing each and every element of this array. So if 40 is equal to what is 40? The element. If it is equal to the first element, what is first element? A of 0. Are you able to understand? If it is equal, then we are saying it is found. Otherwise it is not found. Again, we have to go to 1. How will we do that? If A of 1, we need to put a for loop. Okay, I have explained in detail how the for loop for array works in one of my videos, how to print the arrays. I told you that time itself that program is important. Okay, understand the for loop, then you understand these very easily. Is this clear? Okay, so here I'm going to algorithm to search an element in an array using linear search. So for this, first I have taken one array whose name is A, and then n is the number of elements, because we will fix the array size to say 50 elements and then we may only enter 5 to 10 elements. So n is the number of elements, e is the element to be searched. Okay, and LOC is the, we can put E or we can also put ELE, it's easier. We'll put it as ELE, the element to be searched, and LOC is the location of the element, whether the element is found. Okay, for example here 10, which we took this 40 as the key element, isn't it? The location of the element is 4. Okay, but what is the position of this element? The position of this is 1, 2, 3, 4, 5. It is always the location plus 1. Okay, so here the position of the element is 5, whereas the index value is 4. Okay, and I is the index of the array. Is this clear? So now, as I told you, algorithm is a set of steps. We'll start writing the algorithm for this. So here, step 1, initially I am setting the location to -1 because I want to start it from the first element, which is 0. Okay, so I have set it to -1. In step 2, what we have to do? We have to use the for loop, because we have to traverse the array from the beginning to the end. So what is the first element? We have for I equal to 0 to n minus 1. Okay, we need to put the brackets for I is equal to 0 to n minus 1, the last element of the array. Okay, now we are going to compare each of the element, isn't it? So if a of I, okay, if a of I is equal to the element, yes, then what is the location that we have got? This location, I is the location. And then we need to go to the next step, because already we found the element, isn't it? So we have to go to, this is step 2 here. So where we have to go? We have to go to step 3. This is clear? Go to step 3. But before going to step 3, we have started the if, isn't it? So you should write end of if, and you have started the for. So you will write end of for. After you have done this, end of if and end of for, what we have to do? We have to show the step 3 to the user. So we will say step 3. So what is happening in step 3? Step 3, we have set the location, isn't it? So in this case, in this example, what I took, what is the location? I have 4, isn't it? If this element was not found, for example, 50 was here, if this element was not found, location would have been -1 only. But we have found some value now. We have found it as 4. Isn't it? So we will say if location is greater than and equal to 0, what we need to do? We have to print the location. This is clear? We have to print the location. Else what we are going to do? We will say print search is unsuccessful. Okay, search is unsuccessful. And then what will be step 4? Step 4 will be to just exit. This is clear? Search is unsuccessful and step 4 will be to exit. So this is the algorithm. Okay, first we start with location equal to -1. We are traversing the array, so we will write for I equal to 0 to n minus 1. If a of I, so it will start from I is 0 here. So first it will check the 0 means the first element. If it is equal to ELE, what is ELE for me? The element to be searched. Then location will be equal to what? Location will be equal to I. Then you have to come out of here. So you will say go to step 3. Again, since the location has changed, because you have found that element, it will now print what? It will print the location. Okay, it will print the location. And else, if the location is -1 itself. Initially, we started with the -1. Then you will say print search is unsuccessful and you will exit. Okay, hope so this algorithm is clear. Okay, hope so this is clear. This was asked for 5 marks in this present exam. It's an easy algorithm. Please practice it. Thank you for watching.